Okay guys, this is the second clip on the second half of the sort of section on projectiles, example 9, chapter 6.3. And we're just going to go through this now. So here we go. A ball is struck by a racket at point A, which is 2 meters above horizontal ground. Immediately after being struck, the ball has velocity 5i plus 8j meters per second, where I and j are unit vectors horizontally and vertically respectively. After being struck, the ball travels freely under gravity until it strikes the ground at the point B, as shown in the diagram above. Find the greatest height above the ground reached by the ball, the speed of the ball as it reaches B, and the angle the velocity of the ball makes with the ground as the ball reaches B. As usual, we need to go through the question, lift out the key information, and get it onto the diagram. So 5i plus 8j. Now this is kind, because this time we've been given the horizontal and vertical components of the speed. So we've got 5 meters per second horizontally, and then we've got 8 meters per second vertically. We know that it's a constant acceleration context because it's a projectile motion, and we make that decision at the start of our answer. So we note that it's constant acceleration, and we are going to work vertically. We know u is equal to 8. We're asked to find the greatest height. So what do we know at the greatest height? Well, at the greatest height, the vertical velocity is equal to 0. We know that while it's travelling vertically, the acceleration, is equal to negative g, and the question we're asked for is the height, which we'll call h. We look at the information u, v, a and s. So what is the equation that we know? And I'm sure that by now you're remembering those. So David, have you got it? V squared equals u squared plus 2as. Substituting, 0 squared equals 8 squared plus 2 negative g capital H for the max height. So now we go about solving that, having stated and substituted in the usual way. We get 2gh equals 64. So h is equal to 64 over 2g, which is approximately, I don't know, 3.3-ish. But you can check it on the calculator. So now what do we have? The greatest height above the ground reached by the ball. So as usual, we must read the question back, having got our answer, because so easily we get distracted by that little bit of mathematics. And here's the greatest height above the ground reached by the ball. So max height above the ground, we need to add on the 2 meters from the diagram. So max height above ground is equal to 3.3 plus the 2 meters from the height that it started at, so we get roughly 5.3. But you can check the exact detail on the calculator, please. Remembering that really the answer shouldn't be given to more than 2 significant figures, because we've used g in the question, and that's to 2SF. Okay, part B. The speed of the ball as it reaches B. So the key word in there is the speed. So when we think about speed, we need to have the horizontal and the vertical components, or it's the magnitude of the velocity. Yeah? So when we see that word speed, think magnitude. think, sorry, techno problems again, think magnitude of the velocity, which we usually write as something like that, yeah? But the modulus sign to show me it's the magnitude. So we've got to work out the horizontal and the vertical component when it hits the ground. Well, what can you tell me about the speed horizontally? V in the x direction is equal to, let's look back, 5. Yeah? And that's constant because there's no acceleration. Constant as no acceleration in that direction. And I'm using the little x to show me the horizontal. Show its horizontal speed. Now we also need to think about the vertical speed. So to do that we're going to be using our CVAT equations, constant acceleration vertically, and we know u is equal to 8, and we know a is equal to minus g, and we know that when it hits the ground, s, well, we've not been as careful as we might have been, but we should define our origin, so it's up to us where we put the 0. It's probably easiest to put the 0 at the starting point, A, in effect, and therefore B is at a height negative 2. So S equals minus 2 when it hits the ground. And what have we been asked to find? We want the speed. So again, we need V, the vertical velocity, so we'll call that Vy. Yeah, so it's the vertical speed. Vertical speed or velocity as it hits the ground. So, what have we got then? U, A, S and V. Well, that's nice and easy because it's the same equation as last time, so we state that. V squared equals U squared plus 2AS. V is equal to what we're trying to find, so Vy squared equals 8 squared plus 2 minus G minus 2. So Vy squared equals 64. So now we're solving it. Negative times a negative is plus, so plus 4G. So Vy equals the square root of 64 plus 4G. So now we get to the speed. So the speed, remember, is the magnitude. So the speed is equal to Vx squared plus Vy squared, square rooted, the horizontal and the vertical components squared, yeah, by Pythagoras. So now we can substitute in, as usual, and Vx is 5. For Vy, well, instead of using Vy and squaring it, we can use Vy squared, which we've got up here already. So we can take those and substitute straight in. So we get plus 64 plus 4G, square rooted. So we tap that into the calculator, and we're going to get roughly 25 and 64 is 89 plus another 40, roughly 130. So it's roughly the square root of 130. So that's going to be, I don't know, 11.4-ish, maybe 3, something around there anyway. Again, you can check that on the calculator. Because we're working with gravity, the answer shouldn't really be given to more than two significant figures. So in the end, it looks to me like that will round to 11 metres per second to 2 SF. But again, check the detail. Okay, part C. The angle that the velocity of the ball makes with the ground as the ball reaches B. So, we want a little diagram, and it's probably best to go back to the components rather than use the speed which has been rounded. We'll get a more accurate answer. So our horizontal component has remained unchanged throughout. That was 5 metres per second. And our vertical component that we've just worked out when it hits the ground, and remember, it's not 0, yeah, it's got a speed as it hits the ground, because otherwise you'd never hurt yourself when you're jumping off a wall or anything like that. So, here we go. We've got our vertical speed when we hit the ground was Vy, which was the square root of 64 plus 4g. So the square root of 64 plus 4g coming from above. Yeah, that was our Vy, and Vx has remained the same throughout because there's no acceleration in that direction. So, what else have we got here? We've got our angle there, which is the same as the angle there because they are alternate, remembering those rules from GCSE. Okay, so we know the opposite and the adjacent. So opposite and adjacent would suggest that it's going to be tan theta. So tan of theta equals the opposite, which is a square root of 64 plus 4g, over the adjacent, which is 5. Again, reach for the calculator, 64, roughly 100 over 100, square root it, so it's roughly 2. Yeah, so that's approximately 2. So theta equals arc tan of 2 is approximately to that, so we can tap it in the calculator, and arc tan of 2 is around 63, I think, 64. So again, check it, the detail. But it's going to be around 63, 64 degrees. Again, sensible to round it to two significant figures because we've used G. And that is it for that example. Hope that helps, and I'll sort out the next slot. Homework connected with those two examples. I'm pretty sure we've done exercise C up to 6C up to question 9. So now we need to look at some of these more difficult questions. And really it's the practice that makes the difference, as you know. So homework is page 118, exercise 6C, questions 10 to 16. Let me know how you've got on with it on the sort of the feedback option on Frog, or just by sending me an email. Frog is better because then I can see everybody's at once I've worked out how to do that. Okay, cheers guys.